Chapter 5, Section 2, Properties of Parabolas. In this lesson, what we're going to learn is we're going to learn how to graph the quadratic function, and we're going to learn to find the minimum and maximum values of those functions. So, the standard form of a quadratic function is y equals ax squared plus bx plus c. However, when b equals 0, the function simplifies to y equals ax squared plus c. Okay, we learned back when we were doing absolute value graphing, we learned the vertex, or the x value of the vertex, is nothing more than negative b over 2a. So in this instance, when our b value equals 0, the x value of our vertex equals 0. Okay, with that being said, the graph of y equals ax squared plus c is the parabola with an axis of symmetry of x equals 0. We just proved that. The y-axis. The vertex of the graph is the y-intercept, 0, c. So the c value is our y-intercept in a parabola. So how do we graph a function in the form of y equals ax squared plus c? Well, we graph this equation. The first step is graph the vertex, which is going to be 0, and the y-intercept is 2. So that's easy enough. So the vertex for us is 0, 2. So we can plot that, as you can see on the picture on the right. And then we just make a table of values. We just plug points for x and solve for y. We just plug and chug. The example here, we use x equals 1, 2, 3, and 4. We plug that back into the equation and solve for 4 variables for y. Then step 3, this is important, graph the corresponding points on the other side of axis of symmetry. And then step 4, sketch the curve. Okay, let's look through this example real quick and see what we get. Y equals 2x squared. All right, y equals 2x squared minus 4. So step 1, let's find the vertex. The vertex is going to be 0 since there's no b value, and negative 4. So we can plot that right now on our graph. We'll use red, 0, 1, 2, 3, 4. So we plotted 0, negative 4. I like to go ahead and label that. That's my vertex at 0, negative 4. Okay, now we just got to pick some x and y values. Okay, I'm going to pick x as 1. So when x is 1, we're going to plug it back into the equation. Y equals 2x squared minus 4. So that's going to be y equals 2 times 1 squared, which is 1, minus 4. That's going to be negative 2. So my y value when x equals 1 is negative 2. Now I'm going to choose x equals 2. So again, I'm going to go back to the base equation. Y equals 2 times 2 squared minus 4. Well, 2 squared is 4 times 2 is 8. So that would be 8 minus 4, which would be 4. Okay, so now I have two coordinates, ordered pairs I can plot. First one's x equals 1, y is negative 2. The second one is x equals 2, y equals 4. We stated it earlier, but let's go ahead and just make sure we understand. The axis of symmetry is the x value of the vertex. In this example, the axis of symmetry falls on the y-axis. So my rules are, in a parabola or in a quadratic, I have points on each side that are equidistant from the axis of symmetry. So the point right here of 1, negative 2 is 1 unit away from the axis of symmetry. So 1 unit away on the other side is its corresponding point. The point at 2, 4 is 2 units away from the axis of symmetry. So 2 units away the other side is its corresponding point. So now I have some points, and now I can go sketch the curve. That is it. All right, next example let's talk about. When b is not 0 in the standard form of the quadratic, y equals ax squared plus b plus c, the values of both a and b affect the position of the axis of symmetry. You can use the values of a, b, and c to find characteristics of the graph. So what kind of characteristics are we talking about? All right. The graph of a quadratic, y equals ax squared plus bx plus c, is a parabola when a does not equal 0. When a is positive, the parabola opens up or makes a smiley face. When a is negative, the parabola opens down. The axis of symmetry of the line is x equals negative b over 2a. The x-coordinate of the vertex is negative b over 2a. The y-coordinate of the vertex is the value of y when x equals negative b over 2a. Or we could write it in form of this. The y is the function of f of negative b over 2a. The y-intercept is 0, c. So just on the equation alone, we know a lot of information about these. So here's when we look at the two graphs we got here. Y equals ax squared plus b plus ax squared plus bx plus c. When a is greater than 0, the graph goes up. You can see the vertex is the x value is negative b over 2a, and the y value is the function of that. The axis of symmetry, x equals negative 2a, and then don't forget your y-intercept and its corresponding point. Again, if a was negative, the graph would go down. So graph a function in the form of y equals ax squared plus bx plus c. All right, step 1. Find and graph the axis of symmetry. So you plug in your negative b over 2a, you get x equals 1. All right, that is not only your axis of symmetry, but that's your x-coordinate as well. Plug that value in and solve for the y-coordinate. You get the vertex is 1, negative 4. Find and graph the y-intercept. Since we know the y-intercept is the c value, we can plot that, and we can find its corresponding point or the reflecting point over the axis of symmetry, and then you can sketch the curve. So let's work one. All right, graph negative x squared, okay, plus 4x plus 2. Okay, what I like to do first is I like to label my coefficients. My a coefficient's negative 1, my b coefficient's 4, my c coefficient's 2. To find the axis of symmetry and the x value of the vertex, we go x equals negative b over 2a. So that's going to be negative 4 over 2 times negative 1. So x is going to be negative 2, positive 2. X is going to be positive 2. So how do I solve for y? I just plug that back in to the equation. Y equals negative x squared plus 4x plus 2. So y is going to equal negative 2 squared plus 4 times 2 plus 2. Notice it's negative x squared, so the negative sign does not get squared. So y is going to equal negative 4 plus 8 plus 2. Negative 4 plus 8 plus 2 is 6. So I have a y value of 6 and an x value of 2. So my vertex is 2, 6. So let's plot that. So there's my vertex, 2, 6. My a value is negative, so I know the parabola is going to go down. So what else can I do? I know the axis of symmetry, and I know the y-intercept. The y-intercept is at 2, so I can plot that right now. Okay, let's draw our axis of symmetry. X equals 2. All right, there's our axis of symmetry. Let's redraw my vertex. There's the y-intercept. So y-intercept is 2 units away from the axis of symmetry, so 4 units away from its corresponding unit. So I have 3 points. That's enough for me to graph. And there we go. The vertex is 2, 6. The axis of symmetry is x equals 2. Easy enough? Okay, moving on. The y-coordinate of the vertex of the parabola represents a maximum or minimum value. Okay, we're just going to talk through this real quick. In this example, since the parabola goes up, the y value in the vertex represents a minimum. If the parabola opened down, the y value would represent a maximum of the vertex, okay? So let's move on. Graph 2x squared plus 8x minus 1. Find the minimum value of the function. Okay, so we need to find the minimum. So let's start. Let's first thing do, let's get our a, b, and c values. Our a is 2, our b is 8, and our c is negative 1. So the x value is negative b over 2a, which would be negative 8 over 2 times 2. So my x value is going to be negative 2. So how do I find y? Plug that in. So I'm going to go y equals 2 times negative 2 squared plus 8 times negative 2 minus 1. So negative 2 squared is 4. So 4 times 2 is 8. So y is going to equal 8 minus 16 minus 1. So my y value is going to be negative 9. So there's my y value, there's my x value. So my vertex is negative 2, negative 9. So there we go. We know it's going to go up, so I can put the vertex as negative 2, negative 9. All right. Do I need to really do any graph work? Not really. But what I can do to kind of help ourselves is I can go ahead and draw my axis of symmetry. Okay, so my vertex is negative 2, negative 9. What is my y value? Or what is my c value? Negative 1. So what does that represent? That represents my y-intercept. Well, a point on the parabola is equidistant to its from the axis of symmetry to its corresponding point. So this point is 2 units away from the axis of symmetry, so move it over to get 2 more. Now I have 3 points, and I can graph a parabola. Okay, so I graphed it. It says find the minimum value. Well, what's my y value of the vertex? Negative 9. So the minimum value is negative 9. Okay? Next example. A number of items a company sells frequently is a function of its price. The revenue from the sales of these items is the product of the price and the number sold. The number of unicycles a company sells can be modeled at negative 2.5p plus 500. What is the price to maximize the revenue? So here we go. Let's just talk through it. The revenue equals the price times the number of units sold. So let R be the revenue. That'd be in our mind like the Y value. And let P be the price. That'd be our X value. So let negative 2.5P plus 500 be the number of unicycles sold. We already saw that. So the revenue is going to be the price times the number of units sold. So we factor that out. We get our A, B, and C values. And then to find out our maximum price, we're going to go the price equals negative B over 2A. So when we do the math on this one, we're going to get negative 500 over negative 5. So my P value is 100. So now we just got to plug that value back in to solve for the revenue. Okay. And you can kind of read along there on your notes, and we're going to do the next one together if time permits. Last example. The number of widgets the widget company sells can be modeled by negative 5p plus 100, where p is the price of a widget. What price will maximize the revenue and what is the maximum revenue? Okay, first we got to set up an equation. We need the revenue, which is nothing more than the price times the number of units. Well, the model, or the number of units, is modeled by negative 5p plus 100. So our revenue is p times negative 5p plus 100. So let's distribute the p. So we get revenue equals negative 5p squared plus 100p. So as you can tell, this is a quadratic. So let's find our coefficients. Our a coefficient's negative 5, our b coefficient's 100, and our c coefficient 0. So we need to find the maximum price, or basically the x value or the p value of the vertex. So we can say the maximum price is p equals negative b over 2a. So that would be negative, our b value is 100 over 2 times negative 5. So that's going to be negative 100 over negative 10, which would be 10. So what price, the first question asks, will maximize the revenue? Well, a price of $10 will maximize revenue. The second question asks, what is the maximum revenue? So to find the maximum revenue, all we have to do is plug that back in. So R equals negative 5, our p-value is 10 squared, plus 100 times 10. So 10 squared is 100. So that's just going to be negative 500 plus 1,000. So when you sum that up, the revenue is just going to be 500. So the maximum revenue is $500. Okay, that is it for this section.